Have you ever thought about like how much tech we manage to fit onto these super tiny computer chips?
It's incredible, isn't it?
We're talking like features smaller than the human hair,
Oh, yeah.
and they just keep getting smaller.
Yeah.
It's like trying to fit a whole library onto a pinhead.
Mm-hmm.
But at some point, you hit a limit on how small you can go.
Absolutely. As you keep shrinking these features, what we call pitch size down to like the nanometer scale,
Okay.
you start to run into some real challenges for manufacturers.
So what's the problem exactly?
Well,
Like, why can't we just keep making things smaller with the same old techniques?
yeah, it's the problem is with the way that we create these like intricate patterns on the chips.
Mm-hmm.
Traditionally, we've used these wet resist processes. It's
Okay.
like using a teeny tiny dropper to put ink exactly where you need it,
Right.
and now shrink that drop down to basically nothing and try to place it with atomic precision.
That sounds like a total nightmare.
Yeah.
Especially when you're talking about like billions of these tiny features on a single chip.
Yeah, and it gets even more complicated as those features shrink.
Right.
The tools and materials that we've been using just aren't really up to the task.
Okay.
They lack the precision and the consistency that we need at these just mind-bogglingly small scales.
So what's the solution? Do we just kind of hit a wall and say, okay, chips can't get any better than this?
Well, that's where things get really, really interesting.
Okay.
This is where Lam Research comes in, and they're really groundbreaking dry resist technology, Aether.
Okay.
And the kicker, it might be the key to keeping Moore's law alive and kicking.
Moore's law.
Yeah.
The whole idea that like computing power doubles every couple of years.
Right.
I mean, that's driven so much of the progress we've seen.
Yeah.
From smartphones to the internet and everything in between.
Exactly.
But I thought we were like getting close to the limits of Moore's law.
We may have been if we had stuck with the old ways.
Right.
But Aether, with its very radical dry resist approach, could change all of that.
Hold on, back up for a second.
Okay.
Dry resist, that sounds kind of counterintuitive.
Yeah.
Isn't semiconductor manufacturing all about like etching and using chemicals and liquids?
You're right. Traditionally, it has been. But Aether flips the script. Instead of like liquid ink and a dropper, imagine using like a vaporized material and a stencil.
Okay.
To create these super precise patterns.
Right.
It's a real game changer, and it's much more environmentally friendly too.
Oh, wow. Okay.
We'll get into the sustainability aspect a bit later.
Okay, color me intrigued.
Oh,
So Aether is a dry process.
it is.
You're using vapors to create these tiny patterns.
Yeah.
But how does that actually work? I mean, we're talking about things on an atomic scale here.
It is.
How do you even control something that small?
It is mind-boggling, right? And to be honest, the actual science behind it is really complex.
I bet.
But let's see if we can simplify it a little. Instead of a liquid resisty that needs to be developed and rinsed away,
Mm-hmm.
Aether uses this very special dry resist material that's deposited onto the chip wafer as a vapor.
Okay.
Then using EUV lithography.
EUV.
Yes.
That's a extreme ultraviolet lithography, right?
Right.
So it's basically like using this super-powered laser to create the pattern.
Exactly. It's like using a laser pointer to draw a picture.
Okay.
But this pointer is using light with a much shorter wavelength,
Okay.
which allows us to create these features that are unbelievably small.
All right, so we've got the Aether vapor deposited on the wafer.
Right.
And then this EUV laser edges the patterns.
Mm-hmm.
What happens next?
So after the EV exposure, there's a baking process that basically solidifies the exposed areas of the dry resistance.
Okay.
And then the unexposed parts are just removed,
Gotcha.
leaving behind the really precise pattern we need for the chip circuitry.
So no harsh chemicals.
No.
No messy liquids.
No.
Just a nice, clean, dry process.
Yes.
That sounds like a huge step forward, but is it really living up to the hype? I mean, has anyone actually used this to make real chips?
Oh, absolutely.
Okay.
And that's where things get really exciting. Aether is already making waves in the industry.
Really?
And
Yeah.
who major players,
Okay.
like leading memory manufacturers are already using it in their production processes.
Memory manufacturers?
Yeah.
That's a big deal.
Right.
That means it's not just some lab experiment.
Yeah.
It's actually being used to make, like, the chips that power our phones and computers.
Exactly.
So how is it performing in the real world?
Pretty good.
Is it really that much better than the old wet process?
Yeah, the results have been pretty impressive so far. One major manufacturer reported that
Oh, wow.
after switching to Aether for their DRAM production, they saw a pretty significant increase in yield.
Yield.
Yeah,
That's the number of working chips they get from each batch, right?
that's right.
So more chips with fewer defects, I bet that makes the bean counters happy.
Yeah, they love it.
Lower cost, more efficient production.
Yep.
But it's not just about saving money, is it?
No.
Ether's got that whole sustainability angle, too.
Right.
Tell me more about that.
Yeah, it's a really big win for the environment.
Okay.
Remember all those harsh chemicals and tons of water needed for the wet resist process?
Yeah.
With Aether, those are pretty much eliminated.
Wow.
We're talking about 5 to 10 times less raw material usage
Okay.
and a significant reduction in energy consumption.
That's huge. It's like they found a way to make chip manufacturing greener and more efficient at the same time.
Yeah, it's pretty amazing.
But let's be honest, sometimes these new technologies sound a little too good to be true.
Mm-hmm.
Are there any downsides or challenges with Aether?
Well, it's still a relatively new technology.
Okay.
And there are always challenges when you're implementing something this groundbreaking.
Right.
You know, one challenge is that it requires really specialized equipment and expertise.
Okay.
It's not something you could just plug and play into an existing factory.
So there's an investment cost involved
Yeah.
and a learning curve for the industry. But that makes sense for something this cutting edge.
Yeah.
It's like switching from horses to cars,
Yeah.
You need new infrastructure. People need to learn how to drive.
Exactly.
But let's get back to these amazing companies who are already using this stuff. You mentioned memory manufacturers. Who else is jumping on the Aether bandwagon?
Another big name is IBM.
Oh, wow.
They've been using Aether for some of their most advanced chip designs, specifically for a process called copper damascene.
Okay, now you're just using big words to make me feel dumb.
Sorry.
What in the world is copper damascene?
Haha. It's actually pretty fascinating. Imagine you're building tiny skyscrapers on your chip.
Okay.
Copper damascene is kind of like building the intricate network of wires and connections
Okay.
that run between those skyscrapers, allowing them to communicate with each other.
So it's like the wiring for a super tiny city on a chip.
Pretty much, yeah.
And Aether is helping IBM make those intricate connections even smaller and more efficient.
Exactly.
Wow.
And IBM's seen some really amazing results. They've said that Aether is a key enabler for their most advanced chips. They're calling it the best known process available today for
Really?
creating these crucial connections.
Okay, so we've got memory manufacturers and tech giants like IBM raving about Aether.
Yeah.
Anyone else?
Yeah, there is.
I feel like there's got to be more to this story.
You're right. EMEK, a leading research institute in nanoelectronics,
Okay.
has also given Aether their stamp of approval.
Oh, wow.
They've qualified Aether for use in creating the back end of line or Bayal logic in chips at the 2-nanometer node and beyond.
Bayal logic.
Yeah.
2 nanometers. Okay, my brain is officially overloaded.
Sorry.
Break that down for me.
Okay.
What exactly is Bayal logic, and why is that 2-nanometer thing so important?
Okay, so think of it this way. The transistors are like the brains of the chip, doing the actual calculations.
Okay.
The Bayal is kind of like the nervous system,
Okay.
connecting all those brains together and allowing them to communicate and work in sync.
Right.
And 2 nanometers,
Yeah.
well, that's just insanely small.
Yeah.
We're talking about features that are literally just a few atoms wide.
Wow.
Incredible.
Okay, so Aether's not just helping to create the brains of the chip. It's also building the nervous system that connects everything together
Right.
at the incredibly tiny scale.
Yeah, it's
It's like creating a microscopic superhighway system inside the chip.
that's a great analogy. Yeah.
Right.
And EMEK's qualification is a big deal.
Yeah.
Because it means Aether has proven its capability to meet these incredibly demanding requirements
Wow.
for these next generation chips.
It's amazing to think that this dry process is pushing the limits of what's possible in chip manufacturing.
Yeah.
And at the same time, it's actually better for the environment.
Mm-hmm.
It's not something you hear every day.
No.
This Aether technology really does sound revolutionary.
It is revolutionary. And as with any revolution, there will be ripple effects.
Ooh, ripple effects. I like where this is going.
Yeah.
Tell me more. So we've been talking about how Aether is changing the game for computer chips,
Right.
but ripple effects.
Yeah.
What do you mean by that?
Well, think about it. The drive to make things smaller,
Right.
faster, more powerful.
Yeah.
It's not just limited to computers. We see it everywhere.
Yeah.
Medicine, energy, even space exploration.
You're right. I mean, look at smartphones.
Yeah.
They've gone from these bulky things we could barely fit in our pockets
Yeah.
to these sleek, powerful devices that we basically run our lives on.
Exactly.
And they just keep getting thinner and more powerful every year.
Yeah. Right, and that same drive for miniaturization is happening in other fields too.
Okay.
We're talking about like tiny sensors that can monitor our health in real time,
Wow.
super efficient batteries that could power electric cars for hundreds of miles on a single charge,
Right.
even miniature satellites that could revolutionize space exploration.
So what you're saying is this technology, this Aether,
Mm-hmm.
that was developed to create these tiny features on computer chips,
Right.
could actually have a much wider impact.
Absolutely.
It could spark innovation in all sorts of fields.
Precisely. And that's what I find so fascinating about this. It's
Yeah.
not just about making better computer chips. It's about opening up a whole new world of possibilities.
Okay, so let's say I'm a listener.
Okay.
I'm not a tech expert or anything,
Right.
but I'm interested in this stuff.
Yeah.
Why should I care about Aether
Well,
and dry resist technology?
I think the big takeaway here is that we're on the tusk of a major technological shift.
Okay.
And like any major shift, it's going to have a profound impact on our lives.
Mhm.
Think about the invention of the transistor.
Right?
It was this tiny little thing.
Yeah.
But it completely revolutionized the world.
Yeah.
It led to the creation of computers, smartphones, the internet, everything we rely on today.
So Aether could be like the next transistor.
Potentially.
A seemingly small invention
Yeah.
that triggers this like wave of innovation
Mm-hmm.
and changes the way we live, work, and interact with the world.
It's certainly got the potential,
Yeah.
and even if it doesn't turn out to be quite as transformative as the transistor,
Right.
it's still a great example of how innovation in one field can have these ripple effects
Right.
that we can't even imagine yet.
That's a great point.
Yeah.
It's like a reminder that the future is full of surprises
Mm-hmm.
and that sometimes the biggest changes come from the smallest things.
Exactly.
So if our listeners want to stay ahead of the curve,
Okay.
what should they be keeping an eye out for?
Well, for one, keep an eye on Lam Research.
Okay.
And what they're doing, they're the pioneers in this technology.
Mm-hmm.
And they're pushing the boundaries every day.
Right.
Also, pay attention to the companies that are adopting Aether
Okay.
and how they're using it to create new and innovative products.
So it's not just about the technology itself.
It's about
Watching how that technology is being applied
exactly.
and what kind of amazing things people are doing with it.
Because that's where the real excitement lies.
Yeah.
In seeing how these groundbreaking technologies are used to solve real-world problems and create a better future.
This has been a truly fascinating deep dive into the world of Aether.
It has.
It's amazing to see how something that started out as a way to make smaller computer chips
Right.
could have such a far-reaching impact.
It's been a pleasure sharing this journey with you.
Likewise.
It's always exciting to explore the cutting edge of technology
Yeah.
and imagine the possibilities that lie ahead.
And to our listeners,
Yes.
we hope this has inspired you to stay curious and keep exploring.
Absolutely.
Who knows what incredible innovations are just around the corner.
Exactly.
Until next time, happy exploring.
Oh, yeah.